Good evening, everybody, and welcome to the webinar on how to use artificial intelligence in the inspection program by Ardalan Maghami. We are very delighted to have participants from every part of the world. My name is Samir, and I am the founder and CEO of Notified. We are delighted to present you our newest offering in Academy that gives you premium access to exclusive content, including webinars such as this. For those who are new to Notified, we are an exclusive platform for business professionals. Here, a subject matter expert can earn for their content, a solution provider company can promote their solutions to their target audience, and a business professional can seek solutions and expertise to stay relevant in their roles. What makes us unique is that our machine learning engine scans through the thousands of our business professionals and identifies those seeking solutions. And it then goes ahead and matches them with those who are having solutions, notifies and connects them in real time. What exists today requires you to search. With Notified, a new era begins where you don't have to search. Instead, you will get notified. I would like to thank you for the overwhelming response and wish you happy learning. And for our viewers watching us live on YouTube and Facebook, we apologize that we could not accommodate all those who missed out due to limitations on Zoom. We promise to host you soon in upcoming webinars. I will now pass the mic to my colleague and moderator for this webinar, Farooq Khalifa. He is the co-founder and Vice President, Product Management. Over to you, Farooq.
Thank you, Samir. Thank you. I would like really to thank everybody to take the time and effort to join us for this webinar. Also, I'll thank Ardalan for making the time and effort to offer his experience in the inspection and using artificial intelligence. Let me, in the beginning, I will start with some ground rules. What's going to happen during this webinar that we will mute everybody. However, the presentation will start for almost 35 minutes. After it's finished, we will open the floor for the Q&A session. So if anybody has a question, even during this webinar, you can go up in the bottom of this Zoom. You can find the Q&A chat room. You can address your question immediately and we will take it from there. Or by the end of the session of the webinar of the presentation of Ardalan, we will open the floor so you can ask for the mic. We will unmute you. Just raise your hand and we will take it from there. So let me introduce Ardalan. He's our subject matter expert in Notify. He's the founder of Inspec Integrity, charter engineer with 16 years experience in the inspection integrity management and corrosion control, maintenance and turnout. Within the oil and gas and digitalization focus oriented for inspection integrity activity, scoping for digital projects to develop a knowledge sharing platform. So I would like to really welcome Ardalan, and you want to take the mic, Ardalan, and you can share your desktop so you can start with your presentation.
Sure. Hi, everyone. I'm sharing my screen. Hopefully you can see it well. Can you say it well? Can you hear me well?
Yes, yes, perfect. I think we are okay.
Yeah, hi everyone, I hope you are well and you're doing well as well. So this is a presentation about use of artificial intelligence for inspection and maintenance activities. So as you see, there are a couple of titles. So the first one is about defect, anomaly, and failure predictive artificial intelligence AI inspection tool. That's what we are aiming to describe in this presentation. And another title is about an AI system that can help finding hidden trends and enhance inspection and maintenance strategy. So to start, so we start with who. So my name is Ardalan Maghami, founder of Inspec Integrity, and the Inspectegrity concept is all about early detection of asset integrity threats and issues, either by e-learning or using AI technologies or awareness through internet or LinkedIn posts or other methods of providing awareness and providing kind of education and basically any help which can provide early detection of finding issues early. So we discuss about this concept, why it is critical to find defect early. But before that, we discuss about artificial intelligence as a kind of emerging kind of technology and software. And well, since maybe 3-4 years ago, it become kind of hype in the market, and everyone was talking about it. And just because it became commercially viable, and the reason behind that aspect was cloud computing increased and enhanced significantly, and as a result of that, the artificial intelligence became as a kind of software and tool. The whole AI is kind of old in terms of background, so it comes back to decades. So the main algorithms are quite they've got long histories, but in terms of application, it just became viable, economically viable. Historically, they probably needed a computer in the size of a house to run a model, to train models. But these days, it can be run under kind of cloud computing or software as service, or known as SaaS, which is basically application runs in the cloud servers and over the internet. And rather than buying the whole application and computer, you just need to subscribe to the tool or to the application. And application comes with a server, comes with the software recoding, and so it's a kind of package. And that's the reason for having AI as a new thing or new big thing. In terms of oil and gas, so oil and gas is moving into an era where artificial intelligence techniques will be kind of essential to create the values for inspection and maintenance activities. So a question just popped in. So is your organization? So yes. Kind of create values for inspection and maintenance by finding hidden trends.
Ardalan, maybe I will interrupt you here. We have a pool. We're going to ask some question from the beginning. Maybe everybody see a pool here, question about, is your organization using artificial intelligence in any part of the business at this point of time? So we would like encourage everybody to give us maybe 20 seconds to answer this poll so we can show you the result, because we need to understand where we are today in terms of the audience we have. So please take 10 seconds and give us your answer for this first question. Is your organization using the AI in any part of the business? We'll give it another 5 seconds, and maybe we'll say the result. Okay, maybe Samir, if we have the result, if you can show it to us. Okay, as you can see, we have about 38. They are already in the AI business. As you mentioned, we are moving anyway in the oil and gas and any other part of the industry. So we have almost half of the audiences. They are somewhere in progress. I think the second question will be around the inspection itself. Maybe you want to bring the second question. Yes. Now the second question will focus on the inspection program. Are you using any artificial intelligence type of technology in the inspection program? So you have 10 seconds to give us your answer so you can show the result. Okay. So maybe Samir, if there is any result, we can show it to the audience here. Okay, so even though we have about half of people that are using some sort of AI during their for their business, however, look like for the inspection program, still something in the beginning, like as Ardalan maybe will focus on how this is going to happen. We have 68% of the audience, they are saying they are not using AI in the inspection program. This is the result we have. We have other two questions. We would like really to take the opportunity and ask you about Notify itself. Maybe you saw the Samir give you the introduction about what is Notify. And we need to see your interaction of Notify. Maybe the first question or third question, Samir, about the Notify.
Farooq, that we will be sending as a survey after the webinar is conducted. Then it's
Okay.
a survey question.
Okay, so now we know that Ardalan, your audience here, we have about 50%. They think they're using AI in some sort of somewhere in their business. However, we have about almost 70% of the audience, they are not using it for the inspection program. So this is a good opportunity to tell us how this is going to happen and the way it's been happening somewhere else in the world. So you have the mic, Ardalan.
Perfect, thank you. So back to the topic. So in the oil and gas industry, so we have seen the application of AI and also emerging of applications in different sectors of the oil and gas industry. But in terms of inspection, so it's very critical to find to create values, so to bring values in terms of cash, in terms of integrity and safety, and also identify issues or some kind of patterns in failures and accidents visible to decision makers to make the decision making process faster and more accurate. So once these two parameters are aligned, then that terminology, which is they say, or data is the new oil, that brings its value or its kind of intellectual property to the business, and become some kind of normal in day-to-day activities. So what does the current and future hold for AI for inspection and integrity management of pressure systems? So that's the questions. We start with current. So currently we see application of AI in different kind of projects or businesses or sectors in inspection activities. For example, there are companies do modeling of internal corrosion using trending wall thickness measurements, and they use AI to extract information from silos of data and reports. And that's quite kind of impressive work. It gives decision makers, corrosion engineers, inspection engineers to know where the gaps are and where the system is suffering from corrosion internally. And another aspect, there are companies, or at least one company, identifying and assessing external corrosion using laser point cloud data. So once they captured all the data, laser data of a plant or an offshore platform, which can be done over a few weeks, then they can identify basically lines, because they know the cloud data lines and vessels and the locations, and identify the for example a corrosion loop, and conduct visual inspection of the corrosion loop through the just by from the desktop. So very smart way of doing it. And also there are other application on pipelines, so analyzing pipeline pigging data using AI models to accelerate assessment of pigging data. So historically it was doing by individuals, and it was kind of long and time consuming exercise. So there are kind of technologies or companies working on these aspects. And the fourth one, analyzing video captured by ROV for inspection of subsea pipelines. So again, that's another kind of time-consuming exercise for subsea engineers to go through the whole video, identify where the problems are and how bad they are and how good they are. So this is again one of the technologies we see as part of the AI. But what we are going to discuss here today is more about our idea in terms of a knowledge sharing platform, which works based on anonymous basis, where so there is a machine and operators provide data from, like, data, when we say data means like data from their pipes and vessels and the structures to the machine. So from, for example, operator number 1, operator number 2, 3, 4, etc. And then they get feedback in terms of where the trends of failures are, where they have seen the machine has seen something special by, for example, sharing the knowledge from operator 2 to operator 1 or vice versa. So we will explain this concept more in next slides, and also we link it with our main things, which were how to create value and where the value comes from. So the ultimate aim of this kind of knowledge sharing platform will be identifying and finding hidden trends and patterns in anomalies and failures in pressure system, for example, like pipe work and vessels. That could be on onshore platform or offshore assets. So once we know this kind of information, that would help us to find it, and that would help us to scoping the inspection more accurately. And as a result, we can find it early. And we want to find it early to avoid that defect becomes worse, because once it becomes worse, the whole maintenance will be more expensive. Or if we don't find the defect at all, so it becomes a through wall defect, for example, on a pipe, and cause a leak and a loss of containment, and that could lose as well as the safety aspects of the issue. In the best case scenario, so if it's on a hydrocarbon system, for example, it can cause unplanned shutdown, and that has a significant impact on the economic of an asset. And the last one is if we find the issue late, basically we have to spend more to maintain it, to repair it, to replace it, and sometimes the replacement needs to be done during an outage or planned shutdown. So again, we fill the unplanned shutdowns with unnecessary work or works which could be found earlier and repaired in a cheaper way. So just to explain these things that I just said in terms of to make it more visible for you, and in terms of showing perhaps more pictures and more graphs. So as you see here, so imagine there's a corroded pipe. So if we find it early, in earlier stages, so the integrity issue as any earlier stage can be just repaired by, for example, blasting and painting. But if it's not found, and the degree and the issue or the external corrosion starts degrading, so, and we lost pipe thickness, so it reached to a point that we need to probably apply temporary repairs like composite wraps or mechanical clamps. In that case, so the cost of maintenance and repair will be increased significantly. So I'll just put some kind of indications of and numbers here just to show you how big the impacts are. And if we don't find it, so it ultimately causes leak, through wall defect and failure and loss of containment, So on those cases, if it's on a hydrocarbon system, it's a critical pipework or vessel, so the whole plant or a unit has to go down. And as a result, so we lose production. And that's a significant unplanned shutdown impact, and the scale of loss and the cost will be significant. So from a spot repair with few, for example, $1,000 or pounds, so it goes to in the range of millions, depending on the production of that plant or platform. Therefore, the early detection of integrity threats is key. And because it can minimize the repair cost, it can maximize the production by avoiding unplanned outages. That's the point here. We just mentioned it, and also minimize planned shutdowns. So, and that's where we say value comes from these figures that I showed you. So we want to find issues in earlier stages, as early as possible. And because we deal with perhaps a massive plant or kind of a remote offshore platform with long history and silos of data and in different formats in different places. So the information we're looking for are hidden, and for a decision maker, it takes hours and hours to extract these information, bring them into one place, and make it kind of presentable for just for making a decision. So that's why the importance of having an AI driven tool which provides information like that is key. So I just give you some information now in terms of the problem. So we want to bring a solution for a problem. So let's discuss the problem and let's being more detailed about the problems, what problems we're talking about when we say hidden trends. So what trends are, and what so which when based on what fundamentals we can find them. So the first fundamental is a reoccurrence of same type of defects or failure in a piping system or a vessel in one asset. So for example, one piece of equipment may have failed over the years several times, and different people have looked at it in different period of time. For example, in this case, so failed in 2003, and then 2015, and then 2017. So every time the practice was, well, change it like for like. Perhaps it wasn't visible to people that, oh, this item has failed 3 times, and this kind of repair may not be suitable and may not be capturing the main problem. And due to that operation, they had to suffer unplanned shutdowns for numerous times. So this kind of hidden data is very critical and valuable to be transferred to a decision maker, that this piece of equipment has got this kind of history, and it will be better to make a decision based on that history. So based on the example that I showed you, so the machine we're talking about here, after inputting data, can identify this kind of issues and trends and provide it to the operator to make a decision in a much faster and quicker way. And this is a kind of typical UI UX, user interface or user experience, just explaining what the machine has found, and also with backing of companies or services that can help with this issue. In the second part of main problem, we talk about the second fundamental, which is occurrence of a specific form of defect or failure in a typical piping system or pressure vessel across various assets For example, in one platform or one plant, when a specific nozzle of a vessel failed or had a significant internal corrosion. So the lesson learned from that kind of a very specific form of defect, and other similar equipment in other platforms or plant got inspected, and they found similar issues. So sometimes when an accident or an issue occurs in one plant or platform, they think that they are the first that they experience that issue. But in most of the cases, that issue has already happened somewhere else, but due to lack of communication, so we didn't know about it, or that person didn't know about it, the decision maker. And having that knowledge that there could be a situation where the equipment may fail, they can plan it better, but they can plan and look for the defect. So back to the machine, the information or data is fed to machine, and machine identifies that. So the first basically that separator on asset X suffered the defect, so information is passed to asset Y, and asset Y identified the same issue after doing some inspection, of course. And again, this is kind of information is fed to operator to identify the problem. So if you want to recap the issue, or maybe just showing this one again, so it's a kind of example for UI and user interface, user experience, to explain the problem that one platform had the problem, you may have it as well. And these are kind of technologies that you can find this kind of issues. So there were two fundamentals, if you remember. One is reoccurrence of same defect in one equipment, in one asset. Another one was occurrence of the defect in one asset and having the similar equipment somewhere else and sharing the knowledge. So imagine that kind of sharing knowledge platform exists, which can help perhaps optimizing the risk-based inspection models, which are mostly based on theoretical parameters, for example, theoretical damage mechanism, theoretical corrosion rate. So once you have more evidences that this kind of defects have not been seen across like 10 platforms or 10 plants, so then you can minimize the inspection scope for that kind of damage mechanism. And on the opposite side, if every platform or every plant had that kind of defect, so you can include it as a kind of entry for your damage mechanisms and start looking for that issue. If you don't look for it, if you don't know that you're looking what you're looking for, it's very unlikely that you can find it, or you can find it in an RBI or risk-based inspection remaining life range, I would say. The next problem is about basically the gap across the personnel in terms of the history of the asset. So imagine a group of people are working on asset, and once they're moving by I don't know, retirement or changing jobs or any other reason, so the new team take over, and they probably don't know exactly what's happening in the past. And having that kind of sharing knowledge, it gives them lots of benefit to know what the status are and what they need to look for. And the last one is about so again, it's about kind of reorganization and personal changes and kind of breach the gap for personnel who had lots of knowledge of the asset. So these are kind of problems that we are dealing or we have been dealing over years. So the solution is what we're proposing here is some kind of AI inspection tool which can predict trends and anomalies in failures, which can which can basically act as an anonymous knowledge sharing platform, not only in one asset, it can also share it with other assets and other operators. It can capture knowledge of asset anomaly histories lost due to movement of staff, use anomaly data to anticipate failures and trends in order to improve RBI, and basically to cover up all the problems that we just discussed. So to elaborate the solution, so imagine we have a tag for a pipe or a vessel. So that tag can be found in inspection databases and also in perhaps in maintenance databases and also operation databases. And through that tag, these databases, like inspection plans, shutdown plans, the maintenance histories, the lick and whip and sip registers, fugitive emission register, anomaly databases, management of change, different locations, and start finding applying those two fundamentals we discussed. So occurrence of a specific defect in one asset and also reoccurrence of same defect in just one piece of equipment over the years. And then lesson learned found and shared with decision makers as kind of visualization. It could be visualized or it could be sent as an alert. So how we're planning to do this? So as we discussed, data is first of all is unstructured. It's not really a structured and tidy data, and also it's scattered. It's in different places. The first stage is to consolidate it, so bring it into one place. So once it's in one place, then convert that to a structured data. And once it's in a structured data, it can be searched, it can be investigated. So that's basically the process of the solution at earliest stage. And once the data is structured, then that's where we can apply the models we're talking about. And these kind of NLP models, so it's kind of identify what kind of sentiment that sentence or that failures had in the past. For example, one piping system during 2012 to 2015 has been suffering from like these items mentioned here. So it's a kind of technology that can highlight the problems for the decision makers, and the decision maker can easily see that, okay, that system during that period of time has been suffering from or just suffered from significant internal corrosion, and that's a very useful insight to basically to plan for the next inspection. So in 2020, perhaps that individual doesn't know exactly if he's new to the asset. He won't know that what happened during that time. But by such a knowledge sharing platform, that individual decision maker would understand that, oh, there are some background or some history regarding internal corrosion on that system. And that's key for decision makers, and that's key for inspection, scope setting, and to provide ultimately the assurance for the asset integrity. So we talk about sharing information from one asset, one equipment to another one. So imagine we have like in an offshore platform, we have separation units in every platform, which starts with a wellhead platform, and then it goes to first stage separator, second stage, and then third stage. Kind of typical. Some other assets may have only two based on the level of liquid in the in wells. If we look at one equipment, we may not find enough information for building an AI model or there are not enough information basically. And when you don't have enough information, you cannot train your models, and it's very difficult. But when you have that concept that okay, so we have different equipment, but in terms of functionality, they are kind of doing same thing, and they can be kind of linked together and build that kind of concept that we are looking for, which is a big data for a static equipment. So if you look at a pump, for example, or a compressor, they have lots of data. For example, they have temperature data, they have vibration data, they have pressure, inlet, outlet, suction, discharge. So when you have all this data over the time, so in a time history manner, you got lots of data. You can align them together and then define where the problems are, train your model, and here we go. You have a model for your pump or for your compressor based on lots of data that you've got, but for one piece of pipe. So if you're lucky, you will have some wall thickness measurements using ultrasonic or radiography. Or you can search in your databases and find some repair done, like painting done or some sections been replaced. That's literally what you have. So when you have limited data, you can build a model to do basically anticipation of when it's going to fail. So I explained earlier how other companies use other technologies to do these kind of anticipation or forecasting where the pipe is going to suffer failures. But what we're talking about here is to build that kind of concept that, okay, so this pipe is not alone. There are similar pipes or similar vessels in other platforms that can be get together and build that concept for big data. And once we've got that thing, for example, asset one, or it can be a plant number one and a plant number two for other operator. Equipments have been identified: equipment one, equipment two, 3, 4, and then I start exchanging data, exchanging lesson learned that, okay, this equipment suffered from that issue, so pass it to the same equipment in other platform or assets, showing that, letting know that you may have this issue on your equipment that you have not seen it so far. So this is a kind of heads up or insight that you may need to do more investigation to find out whether you got that issue or not. And for example, this equipment in asset one has got 3 issues and pass it to the other asset. So this kind of exchanging is very kind of interesting if it works, which can work, of course, but it needs lots of entry in terms of data, in terms of operators or platformers assets. So when we talk about data, so the data is fed to the algorithms and predictive models, create that predictive algorithms create the model, data fed to the model, and the solution is created. So it's checked if it's okay. So that's the good news. So that model works. If it's not, so the algorithm needs to generate another model, and that's why where the data is key to run this cycle. And that kind of training AI model is based on that idea. So in early stage, so if you remember what we discussed a little bit earlier, when we have this kind of concept that unstructured data gets converted to a structured data. So in that aspect, so the model needs to be trained to read information from different data sources and make it tidy in one place. And once it's there, so the search engine can run the show and identify insights. So we maybe discuss about this concept that we need big data. We need lots of data. We need lots of platform, lots of operators to have to run the model. And so as we discuss in training a model or AI model, so we need more data. So if data is more, so that's a good thing, because that cycles that we discussed earlier, it will the number of that trials or training cycles will reduce significantly, and as a result, the accuracy of final model will be very good. So rather than being like 50%, it will be 95%. So that's a big difference. So having number of having more equipment, more operators, more assets, it's a good thing for this business. And as it grows, it becomes more accurate and more and faster and also more efficient. So what data is needed? So as you expect, literally any data will be useful, but as a kind of minimum or essential. So all the defects, anomalies, failures, accidents, incidents. So that's whether it's been done or not been done. So that's kind of main thing. Also a list of equipment on that asset, list of corrosion loops or piping groups or any information about RBI would be useful. So the maintenance history would be useful, management of change histories would be useful, and also operational data. And other supplementary or additional data could be emission or leak registers, plans for shutdowns, which one is in future shutdown, which one was in the shutdown. So basically any data which can be fed. So if you feed more data, more accurate data, better data, you get better result. So if we come basically reflect to the initial of this presentation or earliest stage of this presentation, we talk about current versus future. So the current is so there are technologies for AI. They're using AI to develop products, to create values, and they are very successful. And in terms of future, so we need this kind of knowledge sharing platform to investigate, to do two things. So investigate in one equipment, see what the history was, whether there is any trend in failures, and also secondly, share that information with other platforms, equipment in a kind of similar functionality, and tell them that you may have that kind of problem. So this kind of sentiment of the market, where are we heading in the next 5 years? So as we're expecting, or what we hear in news following the COVID and other issues, so we are expecting the demand for oil to be reduced or being low in future due to different reasons. So when oil demand is less, perhaps the oil business will be more difficult and challenging to make it the business more economical. So perhaps the first thing is less expenditure on capex and then also on opex. So in terms of opex, so I mean options are very limited. So less personnel and also less expenditure on inspection and maintenance. And when there are less people and also less budget, so it's very important to know where to go and how to do it. And that's why the role of this anonymous knowledge sharing platform will be key in future. So I think we reached the end of this session. So I've got a slide about what's coming to the notified academy in terms of what Inspectegrity will contribute in a notified academy. So these are a list of topics that we are hoping to work with notified in future to deliver for the benefit of the users. And that's it. Back to you, Farrokh.
Thank you, Ardalan. Excellent, and I think it was For me, when I see these things about how we're gonna utilize the artificial intelligence in different parts of the business, and Notify itself as a platform using the artificial intelligence for making things happen. So the trend is there. I mean, everybody is doing it and everybody is heading this direction. What I was surprised, to be honest, is that the low number of people or company or organization, they are using the artificial intelligence in their current business. Coming to the question, as I told our audience, there will be a Q&A session. If somebody have a question, maybe you want to raise your hand so we can unmute you. Also, there is one question is being asked by Verma. He's asking about how you quantify. I mean, when you deploy the AI technology for this question, I mean, the question is how, when you deploy the AI technology, how you can quantify the return on investment? Because at the end of the day, all these companies, as you mentioned, is try to survive and try to make money. So how you convince somebody who are not using the AI at this point of time, which is, we know right now it's a big number of organizations, they are not using AI. How are you gonna convince them by showing the money, which is how you quantify the return on investment? And if there is any examples that being established to prove this kind of, I will call it claim or assumption at this point, or.
Okay, I think that's a very good question. So that was a question that we kind of provided answer for the time that we were working on raising funds as well for our investors. In my slide, I show where the difference are for early detection, if you remember. So where we find the issue in earlier stages, or when we are kind of notified that we may have this kind of problem in our system, and we start looking for it and we find it early or earlier before it becomes an expensive repair or become a major failure. I think that's the value that that is generated. It can be quantified by kind of kind of assessing the number of days of unplanned shutdowns, how much money the business gonna lose as part of not finding the issue. But it's a very difficult one. But in terms of rate of return is significant. We've done that exercise and the number was enormous, just based on finding one defect per year per asset. So it was significant.
So there has been an application using the AI at this point of time that is proven, that is showing some real good numbers in the oil and gas business. Do we have this kind of cost-benefit analysis being completed or being implemented, so it's showing the numbers, or still this is an early stage, but we know for a fact by just detecting one of these major failure, we're gonna save a lot of money. This is something we predict anyway.
Yeah, exactly. That's the way forward. Yeah, and also it's kind of customized per asset, per history. So it depends how much data they've got, what the quality of the data is. If it's not enough or it's not in the best shape, so perhaps it needs more kind of cost. It's in the higher cost in terms of developing a tool which works for that data, and that would affect the whole rate of return. And also it depends on the production of that facility, the whole item, the rate of return kind of query. It depends on the application. For a low producing, for example, I don't know, offshore platform, or a very kind of old refineries with kind of paperwork, copies of information, with in very early stage, very end of the of its life. Yeah, perhaps it's not very economical to run a program like that, but for different assets, yes, it can be very valuable. So it's kind of customized and case by case basis.
Okay, there was one question actually. Now, as AI coming to the market, a lot of people now they are thinking about the job security and who gonna be replaced by what. And you already mentioned that with less budget, will have a less people working anyway, and you will have less inspections. So, what do you think now? How AI could replace some people job they are doing right now? And what kind of new job will come to the market in this business of inspection utilizing the artificial intelligence?
I think I asked this question everywhere we presented. So if you remember, we had this conversation a couple of years ago in Dubai as well. Yeah, I think that's a kind of a legitimate question, but the answer is no. So it's not like that. So it's not like things that we have seen in the movies. So it's not like that. So at even earlier stages, it creates jobs. So people who are going to work on the AI side and on data cleansing, on developing on the IT side, perhaps, and maintaining it is a kind of job creation. And once it's generated and it's up and running, again, it creates insights. So when you have insights, you need to investigate it, and to investigate it, you need perhaps more people. But it is valuable because you go and look for something that you have been notified. It's not just going randomly and finding something. So that's a different thing, and that's where the value comes from. And in one of the presentations, I'll show you where the UI UX works. So when the issue is sent as a kind of notification at the bottom of it, so the technologies or services which can be provided is backed as well, and that creates more work, but work which is more effective, and it's more likely to lead to something very valuable and finding very big problems, which can prevent major accident hazard, which can prevent unplanned shutdowns, etc.
Great. I think I'm agree with you. That is about not replacing people's jobs. It's by creating another opportunity for making people going to the right place. I think this is the whole concept of AI part of it, is tell you exactly where you need to look and how you can have this early detection happen. A second question I think I have from Mubashir, he's talking about deploy or applying this AI technology. This is will make a more demand on what we call remote sensor and imaging. If this is going to be the case, how this is going to be significantly? I mean, do we still want to rely on people taking data, or because now the AI came to the equation and we need more data, how the remote sensing in the market today can be increased, and what's the relation between remote sensing and AI, and how this is needed to make it, because it's required data and required to be, the model need to be teach.
Yeah, exactly. Yeah. So the AI algorithm, as we call it, so it needs so it generates models. So the model needs data, as we showed in the presentation. So the data comes from, so in our proposal or our presentation here today, what comes from the existing data, the history of that piece of equipment. However, the concept of digital twins or sensors can be also applied, and the data can comes from that kind of section, which is kind of automatic way of data acquisition. And once data is fed to the algorithms, the AI, and then it generates a solution, and if the solution is accurate, that's good. If it's not, so it needs to create another algorithm, another model. But in source of data, it could be either existing data, or it could be through sensors and digital twins, or where we talk about perhaps numbers. So it comes from perhaps sensors, but in terms of photo and images, that's another way of data coming to the model, and then perhaps different model needs to be used to, for example, identifying, I don't know, a valve on that pipework, or identify the valve with corrosion, or identifying valve with broken handles, for example. Yeah. So the model needs to be trained for that aspect. But you're right. So digital twins and sensors are another source of data to AI models to get trained.
Okay, will bring us to the second question. And before I gonna go for a second question, I would like really to ask our participant if there's anybody wanna take the mic and ask the question directly, because to be honest, I'm tired to ask the question on your behalf. I'm okay with this, but I will love to see somebody has the mic open and ask the question directly. So if you would like to ask a question, maybe just in the bottom of the bar you have on the Zoom, you will see there is you can raise your hand, and we can have the mic open to you. Anybody has any question, will ask through the mic. I don't. Yeah, I have one raising his hand. I believe this is Mr. Mubashir. Maybe Samir, if you would like to give him the mic. Mubashir, go ahead.
You can go ahead.
Okay. Hi, everybody. First of all, I appreciate for offering this webinar. I think it's very useful. I would like a little more elaboration on my question regarding the specifically, is deployment or implementing the AI for inspections going to increase or decrease, or no effect in terms of using remote sensors, imaging, etc.? And this is my first part of my question. And second is probably more of a comment, because one of your slides, actually, you tried to justify the usage of AI, artificial intelligence, in inspections because of lack of in terms of capex or opex. Especially in opex, you said, okay, eventually having less people, or maybe not having enough budget for the required number of people. So that kind of contradicts the earlier statement. Yes, there will be jobs in developing the artificial intelligence models and machine learning and all that. But over there, you have just justified that implementing that will enable us to actually work with less OPEX budget. So these are two of my questions, basically, if you could shed some more light on that. And again, I appreciate very good seminar.
Thank you, Mubashir. So the question, if you heard them, Ardalan, he's talking about is a question about creating remote sensoring. Is this will increase or decrease because of the AI? This is the first question, Mubashir, I'm right?
Yes, exactly. So does it increase or decrease?
Okay, so that's the first question. Second question, he was saying that in one of the last slides when you showed the challenge facing the industry today, and this will create OPEX gonna go down, which will lead to less people gonna be utilized. Having less people utilized is gonna help the AI, or gonna make it less valuable, I believe, if I understand the question right.
Well, it's more of a comment. I really believe, let's be open. The way I have understood, it's going to make our inspection works more targeted, more specific, which will actually saving us cost, both in terms of the quality of the inspection and also the manpower implementing towards it. So let's not be afraid in terms of saying that, yes, there will be less deployment of actually people who will be doing the inspections, but there will be other areas in terms of machine learning and model generation and all of that. So this is just a comment.
Okay, thank you, Mubashir. Now, Ardalan, you got that first question, because second is just a comment about having less people that will help. About the remote censoring is going to be, you think, going to increase? What do you think? Because you need more data for a reason.
Yeah, exactly. Yeah, if we get more data, certainly it's better, specifically on one point or one area. If we can, I mean, when we say 1 point, for example, a sensor to gather wall thickness, you know, an ultrasonic sensor, or when we say area, for example, taking photo of an area over the time. So once we have more data, certainly, and it's not necessarily the number of data, it's also the quality of data. So when we get better data, better picture, or better information from the ultrasonic sensor, perhaps, yeah, the model can work better. And in terms of impact on other activities of inspections, again, that's a kind of a rate of return calculations for that specific perhaps project. So it's not necessarily a negative or positive thing. So it depends on the case.
Okay, thank you. What question which is going to relate to this question is about, now, if we think applying these artificial intelligence to an assets and get data, and hopefully you get an early detection. What about old assets? And I think now a question, if somebody already have an old facility, can the AI technology still work for these too old to adopt this new way of doing business? I mean, and I don't know if it's a refinery, maybe 50, 70, 80 years old, using the AI as a part of the business. Is the lack of technology, which is maybe related to the sensors. If we say the AI model have to work only if you have a facility which has more remote sensor that will lead to more data, so my AI model will be more accurate. Do we have this comparison of, say, you cannot do this unless you have that? And this is going to be applicable for all facility where maybe the technology old and there's no much, I will say, a real-time data come to this AI machine to learn and predict. So are the old facilities still can benefit from the AI, and what is kind of investment there extra beside just the model itself?
Yeah, I think that's a very, very good question. Kind of in new era or kind of recent developments are usually are based on the concept of digital asset. So they try to incorporate sensors or items you just mentioned as part of the data gathering platform for that new project. And from day one, they want to put a kind of right foundation for data gathering, and as a result, pass that data to AI models and get them trained. So that's one thing. So in terms of older assets, plants and platforms or refineries, the good thing is they have histories, they have lots of information over numerous generation of people working there, and perhaps most of them are not there available to provide that information. And having that information in terms of what happened in the past would be key for people who are making today's decisions. It depends on what type of data they have. If they have their perhaps inspection report in PDF or Word format, that's a good news. So it's a good point to start reading those reports, converting them structured data, the concept we discussed from scattered data, it could be in different places. So gather them into one place and then start converting them to structured data. Once it's in structured data, it looks like, that would look like a data from, or set of data from sensor. So that's the kind of process we want to implement to convert old, kind of not very useful data into a sets of data which is kind of equivalent to sensor data, if I'm clear enough.
Okay, so I think that being in all facility, it's an advantage of what I heard. It's just the way you want to structure this data in some sort of something the machine learning will able to adopt. Which is bring us to the same other question came, which now, since we need data to train our model and to be more accurate about this kind of prediction on an early detection. And I like the statement you mentioned. I myself, I came from like a rotating equipment background. And you mentioned very clearly with the rotating equipment, you have a lot of data. With the static equipment, the data is a little bit limited, and this is a challenge for inspection program. That's why you see the AI part of the application is well established in the rotating equipment. There's a lot of application today in the market, which is addressing early detection of rotating equipment failure. It's there and everybody using it. But in the inspection, because lack of data create a challenge of how you train your model. And this was a question came from one of our audience here. He asking how these international company who are giant, I'll say, and they big. So big company usually will have big data, and how they are well to work with somebody like you to share their data and train the model. I know there is some good success story, because there's another question in the same line. If there is any success story implementing AI in the inspection oil and gas, and this is almost the same. Obviously, there's big companies who have a lot of assets around the world, which is again a benefit of making the connection between a problem happen here, which can be repeated somewhere else in other facility around the world, that make connection and prevent this failure. So the two questions came at the same time: is the success story and how these big giant companies in the world that own the data are ready to help and work with this kind of project.
Yeah, I'm very happy to see this question, and kind of, I mean, all questions been very good, but this one was very interesting. Yeah, same presentation been delivered to those international operators you mentioned on your question, and they saw the benefit. I mean, I don't think anyone likes sharing data for the security reasons, for also keeping information or intellectual properties as much as possible inside the companies. However, we have seen significant interest from operators. They are willing to. We have. I can name any operators here, but yeah, we have companies, major operators who are willing to join this kind of knowledge sharing platform because they see the benefit. And on back of that, sorry, just one thing. We had to provide lots of information in terms of what the architecture of the business would like to be in order to be secured, how data will be secured. So we provided information, and also how, for example, GDPR compliance will be applied. We show that one as well. And also there were also lots of other questions, like where the models will be held. Is it inside the company or outside the companies? Some people want it out, some people want the model, if you train the model using our data, that's our model, so that's fair enough. Yeah. So there are lots of questions like this, but yeah, I'm kind of delighted to see that question coming. the answer is yes. They are willing to join this kind of knowledge sharing activity because they see the benefit and they see the rate of return we discussed earlier in other question.
Great, great. So right now, my understanding there is, I'm sure we have this discussion, and you told me about these two big giant company in the oil and gas, and they are part of this project. Due to confidentiality, right now we cannot declare who they are. Right now, also part of the same project, there was a success story. I think this is part of the ongoing progress training for the machine learning, and this is part of these two big companies that are using this technology. Now there was a question about the data. How the data you gathered? I know you are doing some sort of agreement with this company, and you get the data. So are you getting the data through some sort of maintenance management system like SAP or Maximo, or how you get the data? And how this data come to your model, machine learning?
Again, it depends on every company's IT system and IT systems, kind of security and the policies they've got. Some are happy to provide information, perhaps in hard copy. Some of them want to be shared via the kind of data transferring platforms. Some people want the activities of training to be happen inside their kind of intranet or the boundary of their IT security system. It depends case by case, but as I showed earlier on, the sources of data are slightly different. For example, some data or maintenance history comes from Maximo or SAP. The inspection data comes perhaps from the report. The information around failures perhaps or anomalies have been recorded somewhere else in another data set. So they are in different places. So where we said, so we start gathering and consolidating a scattered data. That means we are dealing with different type of information in different places. We try to bring them all into one place first. Once they're then be converted to a structured data, and we extract information from each source of data. But again, yeah, it's possible, but it's hard work, and it's getting information from different sources. And again, it depends on companies' policies.
Okay, we are really happy to have you, everybody, and we really see all the questions coming, but we really have a limited time here. I would like to maybe get two questions, and maybe we'll close this session. However, this session is recorded, so if you have some of your friends didn't attend this, we're gonna post it in our LinkedIn page and also in our YouTube channel, and it's already live in YouTube right now. One question, I think, if Elton, you'd like to ask your question directly to Ardalan? Elton de Souzas. If you would like to raise your hand, maybe I will open the mic for you.
Yeah.
Yeah, go ahead.
Yeah. So what are your insights on companies don't migrate on the cloud and they don't adopt machine learning in the future and align with Industry 4.0? Will they perish, or will they last for maybe for the next 5 years?
Okay. Hi, Elton. That's a good question.
Yeah.
Again, the data can be the company's data, when we're talking about, can be stored in a cloud, and we can access it through the cloud, or it can be held in hard drive, and we get it through the hard drive. So it's the information. The important thing is to get the information or data to start working on that data. But where it's held is kind of that company's policy and the basically the benefit analysis they do for their IT system, whether it needs to be stored on the cloud or not. So I think it's something internal. But in terms of our project or our tools, we want the data, whether it's held in the cloud or other places. So we get it and then we put it in cloud or for that machine learning exercise.
Yeah, and what is the future? I mean, if companies need to do this, or if they don't do it, they might perish.
You mean sharing information or?
Yes, sharing information.
I think if they see the benefit, I'm sure that's kind of a no-brainer case for them. But if they don't see benefit in a long run, yeah, they probably decline continuing, or even they don't see the benefit initially. They may say, okay, we're not part of this kind of knowledge sharing thing.
Okay.
But our experience so far is, I think, kind of everyone is keen to join. So from even different continents, so they're keen to join.
Because one question, and I will have a floor for one last question here, but I'm having my own question, if you don't mind, Ardalan. Really, the question came, say, okay, if we show to these companies that other already doing it and they already have something, may create pressure, peer pressure, which is convince them to be more flexible, to be part of such a project, because no one have the answer yet, and no one can afford to continue the way they continue, especially in the oil and gas. You are in a situation be or not to be. And now working around these some sort of protecting data, which it can be well understood about why. But at the end of the day, if there is a way to show the benefit of this project, and somehow you convince your current too early adopter for this technology to release their involvement, this will put more pressure on the other to follow. Because when I see X company doing it, I am in the same business. I'm saying, why not me? And this is what say, let us join this project of knowledge sharing. And I think this is maybe a next step after you get to the point where this project came to a level. Anybody has any question and you want to take the mic, I can open the mic for you, because I believe we'll end at this point. Anybody? If no anybody, I will have my question to you.
Yeah. So I have a question.
Okay,
here.
Okay, go ahead.
Yeah. How about the small players? I mean, how can they, get into this game of, thrones, wherein they can compete with the big players?
I think the good thing about this this platform is there's no, good or a small, or as long as you share data, you get insight, and you're part of a big community. So you share data to the community or to the machine, and you get it back, and that's through the whole system. So it's not just it's not counted based on how much data you provide. It's based on what data. It's based on the fact that you're providing data, you get insight. So yeah, it's kind of balanced for the all parties involved in this project.
Okay.
Thank you, Alton. I'll share my last question here, and we will end this session. Looking at this whole presentation, I see there is a lot of things need to be done, and a lot of work have to happen, and like a prerequisite for what can make an AI project alive and successful. Right now, what is the one major barrier you see which doesn't allow companies to adopt the AI, because looking at the survey we have, the AI is a fact. It's not something as a fantasy or it's a science fiction. It's a reality. It's being used everywhere and everywhere. But for some reason, right now is not being utilized more effectively in the inspection world. What is the main reason for this? And if there is any way to go over this obstacle and make it happen in the next 2, 3 years, whatever, based on the experience you have so far?
Okay, so let's start it like that. So why they have not done it yet? Is that the question?
Yeah, I say why people not, they know the benefit, it's already there in front of their eyes. There is no deny this is like may not work. No, it's gonna work, and there's a lot of applications show you the AI applications. Now in the inspection world, as we see in our survey, about 70% of the audience, they say we don't have it. We are not using AI part of our inspection program. So we're still using the old way of doing things. And the question came to my mind, why? Why we have 70% of whatever organization doesn't yet adopt the AI? What's the reason, in your opinion?
Perhaps the first thing is a lack of data, or lack of enough data, or quality data. So that's the first thing. So for a piece of pipe or a vessel, there are not lots of data. So you may have lots of data if you install sensors. So whether the sensors are in the right place that they should be, that's the first question. And again, the cost of that sensor, they're not usually cheap. So the maintenance of those sensors are also as another challenge. The management of change, because they're getting added to the asset, that's another criteria. So once you can gather information, like gather lots of, or create a pool of data using those sensors, but it comes with cost. Or you can use existing data which are not enough, or in good quality, or in one place or in different place. So that's why we say, so rather than use sensors or use just one little data, so let's get together all and create a pool of data and more data in a kind of shared manner that can kind of manage that kind of obstacle we have been facing in the past to stop us to use AI. But as I showed in the earlier stages of, or also at the kind of end of the presentation, there are companies that use inspection, use AI for inspection activities. One for modeling the internal, the other one for identify the external damage mechanisms. So there are companies doing that. And also what we discuss here is a kind of difference between digital twin and gathering data through sensors, and also using existing data and amalgamating lots of data from different operators and assets into one place and create a big data similar to what you get from sensors.
Okay, thank you, Ardalan. Thank you for all the time and effort you got it for us, and I'm sure we have a lot to learn and a long way to go for our inspection program to adopt AI for all these organizations not yet there. Maybe utilizing this some sort of knowledge we have today and the vision of some big company already in place, will help maybe convincing the other to follow. One thing I would like to ask our audience, if you don't mind, that we're gonna send you a questionnaire to just tell us what is being done so far for this webinar, and how you are find it is what is a good thing and what is an area of improvement maybe for the next one. And as I said, this is already being recorded and will be uploaded in our YouTube channel, so you can share it with your friends if they didn't attend. We have multiple webinars coming. We have tomorrow related to some HSE from Hugh. He's a UK expert in health and safety. Also, we would like to tell you about the Notify Academy. We have some sort of lineup of courses will be coming in different fields, and one of these will work with Ardalan to provide these asset integrities type of courses. Will happen sometime early of October. We will let you know when it is happen. So really, I would like to thank you for joining us today, and I wish you all the best, and let us see you in our new future webinar. If you would like to join us tomorrow, please let us know if you didn't join yet. And we have another series of webinar coming soon, so please stay tuned and look at our banners everywhere, LinkedIn and other places. So thank you, everybody. Thank you, Ardalan. I wish you all the best. Keep in touch. Thank you. Have a good day.
Thank you.
Bye.
Cheers. Bye. Bye.
Yes, thank you.
Bye.